let's talk about chromatic invention, Bela Bartok. So we're going to analyze a piece called Microcosmos, which we're just going to analyze one of them. It's a group of 153 piano compositions. So there's 6 volumes of these things, and they range from super easy, like the one that we played that shows by modality, to the extremely, like, insanely crazy difficult. So what we get introduced to with Bela Bartok is the idea, and this is the first step into actually doing serialism as well. So I want you guys to have a good grasp of this. But this is called set theory. All set theory is pulling out certain pitches that keep getting repeated in a piece. All right? And it will be very, very, very obvious. Because it's the same set of pitches that keep getting over and over and over again, and they're almost always in succession to each other, right? So it's not going to be spread out throughout the piece. It's going to be one melody is quick succession in this set, and then another melody will be in this set of notes. So all a set is a set of what they call pitch classes. All it is notes. So each one of these, the F, the A, the B flat, they're all a pitch class. And if you put them together, so the F, A, B flat, then you call them a pitch class set. So it's just fancy lingo for saying these notes go together and they keep getting repeated. Now, with pitch classes, enharmonic spellings are considered equivalent. So C sharp, similar to the Stravinsky, C sharp and D flat, they're the same pitch class, all right? So they're the same pitch, the same tone. They're going to get counted the same. They're totally interchangeable with each other. So what you're going to do is take these sets and actually assign numbers to them. So in this case, and we'll call them trichords, tetrachords. It just depends on how many pitches are in the class set. So in this case, we've got a trichord, so that just means there are 3 notes in the pitch class set. And you're going to give the lowest note a 0. So he gets called 0, and then you're going to go in half steps and just count in half steps. So F to G flat and or F sharp is just 1 half step, so that becomes 1. All right? Now if we go from G flat to G natural, that would be 2. G natural to A flat would be 3. A flat to A, we call 4. So this is our pitch class set. F, G flat, this half step, and then F to A, which is a 4th, right? Or F to A is a major 3rd, which means there are 4 half steps. That's going to get called 4. That's all there is to it. So, and you can see like a major scale, for example. So it's basically just assigned on the chromatic scale. So you've got 0. If you had a C sharp or a D flat here, that would be 1. D natural would be 2. Oops, I smudged that. E flat or a D sharp, right? So if we had E flat right here, that would be 3. Right? E is 4. Next half step, F is 5. If we had an F sharp here or a G flat, doesn't matter, that would be 6. G is 7. G sharp or A flat would be 8. Right? A natural is 9. B flat or A sharp would be 10. And then B natural is 11, right? And you're thinking, Callie, there are 12 chord tones. Why does it only go to 11? And that's because we're counting from 0 and not counting from 1. So keep that in mind. So we go from 0 to 11, not 1 to 12. All right, so it's all just half-step intervals. So if we look here, this tetrachord, all that means is that there are going to be 4 notes in the chord. A pentachord, like a pentagram, 5 notes in the chord. They could be any notes, but they're calling it a pentachord because there are 5 notes in the chord, so that you could see these in chord form stacked vertically. You could also see them horizontally, so they're just 5 notes in the set. All right, and then of course a 6-note set hexachord. All right, a 7-note set would be a decachord. So you just keep adding to it. Usually the most you're going to see is about 6 pitches, though. Just keep that in mind. So in this case, the interval, right, from F to F is 0. So 0 half steps. So that's interval 0. From F to G flat and or F sharp, so it could be written either way, that's going to be a 1. That's 1 half step. All right, so you're just counting half steps. F to A, again, right, from here to here, that's going to be 4 half steps. So then you're going to give it the number 4. Does that make sense? I hope so. If it doesn't, we're totally screwed. So moving on, what you're going to generally see is not when you're actually looking at the composition in the wild, you're not going to see a nicely laid out from lowest to highest pitch class set. All right? They're going to be in a crazy order. They'll be all jumbled up, and so you've got to identify, oh, this is the lowest one, and then, oh, look at that, E flat actually should come down an octave. So you always want to make it, just like when we did triads and we put them into snowman formation, into root position, or smallest, basically the smallest spread that we can make it, the most compact that we can make it. We do the same thing here. So this is our normal order. So this would be called the different order. This is probably what you would see in a composition, and add a bunch of rhythm to it and a couple other parts. So this is going to be our normal order. So it's just whatever is most compact, and you're going to start with your lowest note and end with your highest note. Now, you will also see these transposed. So here we start on D, but we've got a half step, another half step, and then we jump up a fifth, right? Or jump up a perfect fourth, so 5 half steps. Now here, it's the same thing. Our lowest note, so this is how we would see it, right? All messed up and spread out. So you want to put it in its closest order, so 0, 1, 2, 5. So again, here we're starting on the C, but we're giving C 0, because that's the lowest pitch in this little class set. And then we move up a half step, and then we jump up a perfect fourth, right? So we're still going to give this a 0, 1, 2, 5 class set. Even though it's starting on C, we just call it a transposed class set, right? So it's just moving over, just moving the whole thing up. All right? So we also can see inversion is quite common. So sets like chords can be inverted. In inversion, the original direction of the intervals is turned upside down. Consider the 3-note set in 16.28. So in this case, we've got a major 2 and then a minor 3. All right, so the inversion of this set, it's going to be, so from here to here, C to D, we're going to have the opposite. So it's going to be a major second down and then a minor third down. So we definitely will see this inverted, and you'd still call it a 0, 2, 5 or 0, 3, 5. So it's going to be starting on the lowest note. The inversion set would be written in reverse order. But there's actually a really, really tricky way to actually determine an inversion and whether something's an inversion. And I'll show you in just a second. So in this pentachord, you can see that the spacing is exactly the same. So from G to A flat, minor second, and then the opposite, from A to G sharp, minor second. A flat to A natural, augmented 1, right? And then from G sharp to G natural, augmented 1. Then we go out to a major third, right? So this one goes down a major third, this one goes up a major third, and it's always going to go opposite. And then down a minor second, up a minor second. So it's going to be 0, 1, this is 5, 6, 7, this is 0, 1, 2, and then 6, 7. So they're inversions of each other, but there's a trick to figuring out these inversions that's even better. All right? So actually there's 2 ways to figure out these inversions. So the first one is to take this inversion, all right? So this inversion, so you want to find the inversion pitch class set of this pentachord, 0, 1, 5, 6, 7. All right, so you're going to start with 12, and you're going to take each number. So 0 minus 12 is 12. 12 minus 1 is 11. 12 minus 5 is 7. So you're going to subtract the set from 12. And you're going to come up with this number, 12, 11, 7, 6, 5, which isn't even close to the inversion that we're looking for. All right, so these numbers represent the inversion, but they're confusing because the set does not begin with 0. So you don't have a 0 here. So now you're going to take the lowest number, so in this case it's 5, right? And you're going to basically turn 5 into 0 by taking these numbers and then subtracting. You're going to subtract 5 from each of these, so you can see it down here. So 12 minus 5 is 7, 11 minus 5 is 6, 12 minus 5 is 2, 6 minus 5 is 1, 5 minus 5 is 0. So you've got 0, 1, 2, 6, 7. 0, 1, 2, 6, 7. As opposed to 0, 1, 5, 6, 7. Pretty cool, right? Now, there's an even easier way to do this. Are you ready? What you can do is just work backwards. So from here we assign a 0 to our lowest pitch, right? So 0, 1, 5, 6, 7. Now if you really want to determine if it's an inversion, all you have to do is work backwards. So in this case, assign the highest note the 0. So give D right here a 0. And then you're going to work your way backwards so you're just going to work your way down, but add the pitches, all right? So you're still just going to count the half steps and whole steps. But now you're just going to start it backwards. So D to C sharp is 1, right? So that's a half step. And then C sharp to A, right? That's going to be, so half step to 1. If we go down to C natural, that's going to be 2. If we go down to B natural, that's 3. B flat is 4. And A natural is 5. So this becomes 5. If we go down a further half step, that becomes 6. And then a half step further, 7. Pretty tricky, huh? So it's just the reverse. We've got 0, 1, 5, 6, 7. And then all you need to do is figure out to find the true inversion. Then you just have to analyze this regularly and find its normal pitch class set, which is starting from the bottom. So 0, 1, 2, 6, 7. But if you're not sure, this is the easiest way I find to determine whether it's an inversion. Is just start with the top note and then work backwards and see if they match up. And you could do the same thing with this. You could start with this top note and work backwards, and you would come up with this number. Pretty slick. All right, so normal order obviously is you're starting with the lowest pitch, and you're going to